All right, hello everyone. So I'm from Sunswap. I hope I haven't used it. Oh, there we go, Alastair. So Sunswap, we are a manufacturer of an electric transport refrigeration system. And as Shane touched on, when people think about road haulage and the impact it has on the environment, their minds go straight to the biggest culprit, which is the tractor unit at the front. But there's a dirty secret within the industry, which is depicted very well by this image here. So as you can see along the top there, you've got all of these temperature controlled trailers, and they not only carry our children frozen food, but they also carry pharmaceutical goods as well. And as you can see, all the emissions going across the top there, that's being produced by the fridge systems that's powered by an unregulated diesel engine. And across the globe, globally, they're emitting circa 50 million tons of CO2 and about 5 million tons of nitrous oxide every year. So Sunswap came into existence actually in this very building nearly 4 years ago. And the reason, or our aim, was to produce the world's most environmentally friendly transport refrigeration system, but is also viable. And by viable, there's a number of things, but main things we focused on is, first of all, range. It needs to be able to do the same delivery cycles, the same routes that customers do today without any operational negative impact. It needs to be financially viable. If it costs the earth, you're not going to get mass adoption. And lastly, it needs to just really be a better system. So similar to EV technology and its counterparts, they're regularly just a better system. So we've developed this, which is Endurance. It's a battery and solar-powered transport refrigeration system. The big box on the front of the other big box is us and the solar panels across the roof. First of all, one of the things we've done is made sure it's autonomous. So we don't need to draw any power from any other power sources, such as via axle regen or power takeoff units, because basically you're just then diverting the diesel burn from the old tractor unit to the front, from the fridge to the front of the tractor unit. The other thing that we've been able to do is to improve the uptime or the utilization time of the system. So we're taking about 1,000 data points in real time from the system, which means we can do predictive maintenance, so identify issues before they become a problem. And most of those issues can be solved through software updates. And in fact, while the fridge is in operation, again, supporting uptime. The more the trailers are utilized, the less trailers you need, and that also has an environmental benefit. One of the key USPs of our systems is the adaptive battery and charging capability. So there is no one exact type of haulier. Everyone's different. So if you imagine you're moving ice cream at -25 in Malaga or milk in Scotland at 3 degrees, you've got hugely different power requirements, and the batteries are A, expensive, and B, heavy. So we've made sure they're adaptive so we can tailor them to every single operator's requirements, so it makes it, again, financially viable for them. And then the last bit that I want to just point out is the biggest challenge is getting over range anxiety. So we're able to probably do about 90%, 95% of all delivery cycles in the UK off of a single charge, therefore not relying on needing a network of chargers. So in relation to the topic today of farm to fork, we've seen a number of challenges with some of our customers over the last couple of years, really just from moving the food as quickly as it can from the farm to our plates. And that comes in the form of field heat. So there's not enough time sometimes to cool down the produce so that it's at the right temperature or the set point temperature of the trailer. So it's worth pointing out these fridges, whether they're diesel, they're electric, whatever, they are not designed to bring down the temperature of the produce. They're designed to maintain the correct temperature whilst it's in transit. But that doesn't always happen, because it isn't a perfect world. So I'm going to just show you 2 telematics graphs of exactly the same delivery cycle and the impact. So, number 1, so this is the telematics of our 4 hours, 40-minute delivery cycle. Golden line is the ambient temperature. The green line is the state of charge of the batteries, that's referenced on the right-hand side there. Dotted purple line is the set point, which is 3 degrees. And the blue line is the temperature within the trailer. So it was loaded just before midnight, and actually the temperature of the produce is under the set point. But as you can see, over time, it basically just gets slightly warmer, but you see up there, there's zero consumption. So the fridge actually never needed to turn on because the thermal efficiency of the trailer was good enough to just transport the goods at that required temperature. So here's a few days earlier, and you can see a dramatic difference. So it's exactly the same produce from the same supplier, but you can see straight away the state of charge is dropping dramatically, which tells us the fridge is on, and the blue line has now become very squiggly, and I'll talk you through what that means. So what we've done here before loading is a pre-chill, which has taken about 20 minutes to bring it down to the bottom of the temperature band. You've then loaded the produce, and as you'd expect, doors open, temperature goes up. But rather than the produce bringing down the temperature within the trailer slowly, it's actually rising, you can see during this period here. And then the doors are shut at about 10 to 1 in the morning, and it's taking 50 minutes. And the fridge is working really hard to bring it down to temperature because it's warm. We're then getting these spikes, which are defrosts, and that's because with heat creates moisture. You get ice on the coils, and you need to remove the ice to allow the air to flow. So basically, rather than using 0 kilowatt hours, we've had to use 16 kilowatt hours to do the same delivery cycle. So what does it mean when you extrapolate that out across a year? So this graph here shows us the average daily consumption for the delivery cycle for every month of the year. As you'd expect, energy needs to increase as it gets warmer. The orangey bars, they depict basically the amount of energy that comes from that comes from the solar panel. So when it's at the correct temperature, we're really maximizing the use of the solar panels, and basically you can run the thing without ever having to plug it in. So environmentally friendly, free clean energy, a lot more cost beneficial. And this customer was saving circa 32% on total cost of ownership over 10 years. Mix that with when you have a warm load, and this isn't when it's happening all the time, it's mixed with some normal, at the correct temperature, some warm. And you can obviously see a dramatic difference. The amount of energy that we can utilize from solar drops to 30%, so we're having to charge it more regularly, which obviously increases cost. But as I mentioned, you need more energy, therefore you need a bigger battery. The bigger battery to do that, so we can do it, but it costs about £14,000 more, so it dramatically drops the total cost of ownership. So is it now financially viable, and is it preventing adoption of this technology? And as I mentioned, this isn't just an issue for electric powered fridges, it's for diesel also. So this operator has circa 600 trailers, so they're a medium to large operator. And just from the routes where the temperature of the produce is warm, they're wasting 750,000 litres of diesel. This is the environmental impact that's coming from these delivery cycles. And then financially, it's costing them circa £1 million a year in additional diesel. So how do we overcome this problem? And obviously Shane's mentioned it's a complex issue because there's so many stakeholders, the retailers, the regulators, the suppliers, the manufacturers, etc. Most of them are competitors, so they don't really like being in a room together agreeing on things. But it's detrimental, not just in terms of environmentally and burning diesel, but in terms of the mass adoption of alternative power sources. So it'd be good to hopefully field some ideas, maybe not all questions, some suggestions of how we can overcome this. One way is that for chilled produce specifically, it doesn't necessarily need to be carried at 3 degrees. Regulation states it needs to be under 8 degrees, and I think they suggest around 5 degrees. So if we change the set points to those numbers, we see some really good improvements just as an option. So the black bars represent the energy consumption by delivery cycle for each month when the set point was at 3 degrees. As you can see, we increase it to the set point within the trailer being 5 degrees, and we save 36%, which is then relates to OPEX saving and environmental savings. We increase it to 7%, so still within our 8% threshold, and you get a massive saving of 70%. And as I say, it just then makes it far more financially viable. They need a smaller battery, and it will work for that customer to operate those systems. But as I say, it's not necessarily an easy thing or a one solution that resolves everything. But There's other issues we see, running the fridge with the doors open. Hopefully there's some thermodynamic engineers that realise that doesn't make sense. And produce going in wet. There's all these very different issues that means that within the trailer space, we're using far more energy than we need to.